This video is on the objective identify and explain differences between one and two-tailed hypotheses tests. Alright, this is the first video, number 1, as you're seeing here on the title card. The first video on a question related to this objective in your Newton-Alta homework. So it's going to be a little bit of a longer one. I'll explain more of the process of hypothesis testing again, and how do we determine what kind of a test we're dealing with, what kind of a test we're performing. Are we performing a one-tailed or two-tailed test? Also, if it's a one-tailed test, is it a right-tailed test or a left-tailed test? So let's take a look. Now here's the question, but again, before I get into this question, I would like to go over some more of the, now we're going to just start diving deeper into the steps of hypothesis testing. So there was one step. The first step was forming the hypotheses. Right, you're going to have a claim that is made about the population. Right, somebody makes a claim about a parameter, like say the population mean or the population proportion, mu or p. And then we want to test that claim. All right, well, from that claim, two hypotheses are formed, and these are two opposing hypotheses. One is called the null hypothesis, and it's usually symbolized by h sub 0. And one thing about the null hypothesis is that it always involves equality. It always involves some kind of an equal sign. Right, now, in this particular text, in your Newton-Alta text, what they show you in more instruction, the null hypothesis will always involve just the equal sign, but I'm just showing you here. I've seen other texts, so in case you're looking up things online, looking up other videos or whatever, looking at other books even, the null hypothesis could be that the population parameter is equal to some value, or that the population parameter is greater than or equal to some value, or it could be that the population parameter is less than or equal to some value. One of these three things, not all of them, right? Or, I've got the word or in there. One of these three things will be written as the null hypothesis. And then when we go to do the hypothesis test, what you're going to be assuming to be true is that the parameter equals a certain value. So that's why very often, instead of writing greater than or equal to, less than or equal to, what is written is what is going to be assumed about the parameter. We're going to assume that the parameter equals a certain value. So very often you'll just see the null hypothesis involve just equals. But let me just tell you, it could be greater than or equal to, less than or equal to as well. But what we're going to be assuming is the equal part. But it always involves equality in some way. All right, and then the opposite of this, the contradiction of this, the negation, is the alternative hypothesis. So the second hypothesis formed after some claim is made about a population parameter is the alternative hypothesis. Now, this is usually labeled h sub a. It's a lowercase a there, sorry. Or in some books I've seen h1, because that's the null hypothesis is h0. So this might be called h1 sometimes, but in this book it's ha for alternative. I can't spell either. That's an N. Alternative. There should be an N in there. I apologize. Anyway, the alternative hypothesis is a contradictory statement to the null hypothesis. And since the null hypothesis will always involve some sort of equal sign, equals, greater than or equal to, less than or equal to, the alternative hypothesis will never involve equality. It doesn't involve an equal sign in any way. Alright, so here are your three possible, again, just one of these three, not all of them. Right? One of these three will be your alternative hypothesis. So one is that the parameter is just simply different from a value, right? That the parameter is not equal to some value. When you have this symbol, if this is your alternative hypothesis, then you're said to be performing a two-tailed test. Because the value, if the parameter is not a value, that means that parameter could be greater than or less than that value. So you're on either side, you're in either tail. Right? Whereas if the alternative hypothesis is that the parameter is greater than some value, well, that's being strictly to the right of some value. So if your alternative hypothesis is looking like this, then you're said to be performing a right-tailed test, which is an example of a one-tailed test, right? A right-tailed, you're on one side of a value. Or, another version, another way your alternative hypothesis could look is that your parameter is, less than some value. And if you're less than some value, that means you're to the left of that value. And if your alternative hypothesis is like this, then you're said to be performing a left-tailed test, right, which is another example of a one-tailed test. So it's very easy, and you'll see with the example I show you here, and I'll have a second video on this objective. It's pretty easy to determine whether or not you're performing a two-tailed, right-tailed, or left-tailed test. Now, what the difference between these tests are comes into play when you're performing the actual test itself, when you're actually trying to lead to a conclusion. Now, if you recall, if you've seen my videos on the other objectives from this particular section, there was an objective on understand the process of a hypothesis test, and there was another objective titled understand key terminology in hypothesis testing. In both of those, I went through the procedure of hypothesis testing, the 6 basic steps we're going to be performing. And I told you in those, and I'm telling you here as well, there's 2 different hypothesis testing methods, 2 different approaches that you could use. One is called the critical value approach, where you set up a rejection region and then see if your test statistic for the sample you take is in that rejection region. And then the other is called the p-value approach, where you find your test statistic for a sample, then you find the probability, the p-value for that particular test statistic, and compare the p-value to what's called the significance level, or alpha, for the test. All right, so what I've done is I'm going to show you here now. I'll bring these back. Right, this is a very introductory section, so a lot of this might not make perfect sense right now, but hopefully it will when we get to other objectives, when we're actually performing hypothesis tests. So if I'm performing a left-tailed test, well, first you find the test statistic, for your sample. And the test statistic is usually going to be like a z-score or a t-score or other things, but for the most part we're going to be working with z's and t's. So you find your test statistic for your sample. Now, if you're using what's called the critical value approach, and you're doing a left-tailed test, the critical value, so you're going to have a distribution to work with, whether it be a normal distribution or a student's t or something else, but you're going to be looking at some sort of sampling distribution, the area under a curve. The critical value in a left-tailed test is the value on the number line that has an area of alpha. Remember that alpha was the significance level. The critical value has an area of alpha to the left. So the value I'm looking for, this critical value, is whatever value is in the number line that has an area of alpha to the left. And this area to the left is going to be called the rejection region. And then you take a look at all right, now where does the test statistic fall on the number line? If the test statistic is at the critical value or less, you're in the rejection region, so they would say you would reject the null hypothesis, that H0. And if the test statistic is to the right of it, if it's greater than the critical value, you're not in the rejection region, you don't reject the null hypothesis, or you fail to reject the null hypothesis. Now, if you're doing a left-tailed test with the p-value approach, and again, if I'm going through this quickly, it's because it's an introduction. We're not going to dive too deep yet. We'll see these again in other videos. But if I'm performing a left-tailed test, you find your test statistic again. Now, if you're using what's called the p-value approach, you mark off, hey, where's my test statistic on the number line? And then what's the area under the curve, under the distribution, to the left of that test statistic? This area to the left is called the p-value for that test statistic. And then you compare the p-value to the significance level. If this area here is less than or equal to alpha, well, that means my test statistic is in that rejection region I showed you on the previous page. Right? It would mean it would be over here in this where there's an area equal to alpha. So if this area to the left of the test statistic, if it's less than or equal to alpha, you reject the null hypothesis. And if the p-value is greater than alpha, you don't reject it. All right, and then the right-tailed test is pretty similar, but instead of everything being to the left, it's to the right. All right, so for a right-tailed test, when you're doing this critical value approach, your critical value is the value on the number line with an area under the curve of alpha to the right. And then if your test statistic is at that critical value or greater, you're in the rejection region. You would reject the null hypothesis, whatever that is. And if your test statistic is left of critical value, less than the critical value, you fail to reject it. You're not in the rejection region. You wouldn't reject whatever that null hypothesis is. All right, and then same thing for p-value, but instead it's area to the right. A right-tailed test, if I'm doing this p-value approach, you find your test statistic, right, not critical value. You find your test statistic, you mark off where that is on the number line, and then you find the area to the right. All right, it's a right-tailed. Find the area to the right. And that area to the right of the test statistic, this time, is your p-value. And then you do the same comparison to alpha as I did with the p-value approach before. If the p-value is less than or equal to alpha, you're going to be rejecting whatever the null hypothesis is. If the p-value is greater than alpha, you're not going to reject the null hypothesis. And again, if you notice too that this is the same comparison to alpha that was made with the p-value approach for the left-tailed test. I think I might have said that already. All right, now for a two-tailed test, it's a little bit trickier. So for a two-tailed test, if you're doing this critical value, what's called the critical value approach, there are two critical values you need to find. I'll call the one on the right critical value 1, and I'll call the one on the left critical value 2. And again, there are two critical values. One of them has an area of half of alpha to the right, and the other one will have an area of half of alpha to the left. That way, the total area of the rejection region is alpha. Right? You have half alpha to the right of this critical value, half of alpha to the left of this critical value. So again, the total area of all the rejection region is alpha. And then again, it's just a matter of, you find your test statistic and compare it to these critical values. If you're in one of these rejection regions, then you reject the null hypothesis, and if you're in between them, you don't reject. So if the test statistic is greater than or equal to critical value 1 here, the right critical value, or if the test statistic for our sample is less than or equal to this critical value on the left, then we're rejecting the null hypothesis. If the test statistic is between them, not in either of these, then you're not going to reject. You're going to fail to reject the null hypothesis. And then again, a little trickier also for the p-value approach. So a two-tailed test, and again, I'll bring these pages back multiple times later when we actually perform hypothesis tests. Right now, it's all a bunch of introduction. So if you're doing a two-tailed test and using this p-value approach, you have to pay attention to your test statistic. If you calculate the test statistic for the sample you have, if the test statistic is to the right of center, if the test statistic is above the mean, then to find the p-value, you find the area to the right of the test statistic and double it. And a little tricky, and two-tailed double, okay. Find the area to the right of the test statistic, then the p-value will be double that area, 2 times that area. Now that's if the test statistic is, at the mean or greater. If the test statistic is, at the mean or less, right? If the test statistic is left of the mean or less than the mean, less than the middle, then to find this p-value for the test statistic, you find the area to the left, all right? Find the area to the left, and then double it, all right? Like the first scenario. So the p-value here is area to the left, and then double that area. And then again, you compare the p-value to the significance level in the same way I did for the p-values for right-tailed and left-tailed tests. If this p-value is less than or equal to alpha, you're rejecting the null hypothesis. And if the p-value is greater than alpha, whatever the significance level is, then you're not rejecting. You're failing to reject the null hypothesis. Right? So again, that's a lot. And again, I will come back to these pages over and over again as we perform other hypotheses tests. All right, so let's go back to the question. So here, a trader claims that the proportion of stocks that offer dividends is different from 14% or 0.14. If the trader wants to conduct a hypothesis test, should they use a left, right, or two-tailed hypothesis test to analyze whether the proportion of stocks that offer dividends is different from 0.14? All right, so I'm going to do this on paper. All right, now you could already tell me probably based on what I showed you, but let's go to a piece of paper here, and I'm going to write out what I would do if I was performing a hypothesis test. Right? So first you have a claim. Now, if I read it again, they said this trader claims that the proportion of stocks that offer dividends is different, meaning is not equal to 0.14. Now, I don't want to write this out every time. This is a population proportion, right? This is a population proportion, so I'll call it P. P is not equal to 0.14. Now, notice that this does not involve equality. It's not equal. So this is going to be the alternative hypothesis. And I'll write out the hypotheses in a second. All right, so the null hypothesis, and you have the alternative hypothesis. Again, since this claim does not involve equality, this claim will be represented by our alternative hypothesis. All right, so the alternative hypothesis is that the proportion of stocks that offer dividends is not 14%. Then the null hypothesis is the opposite of that. What's the opposite of is not equal to? It's is equal to. So the null hypothesis would be that the proportion of stocks that offer dividends is equal to, And this is what's going to be assumed when we do our test later, but we're not going to do a test right now. Now, look at the way the alternate looks. Right? Whether you're doing a left-tailed, right-tailed, or two-tailed test, all depends on how the alternate hypothesis looks, how the alternative hypothesis looks, and I showed you this here. All right. If it's that the parameter is not equal to a value, that means you could be on either side. So that's a two-tailed test, right? So if we were performing a hypothesis test here based on the way my alternative hypothesis looks, we'd be performing what's called a two-tailed test. So back here, two-tailed, and I think that's all you're asked. Let me see if there's a second part to the question. There is, okay. So here, another trader would like to carry out a hypothesis test about stocks that offer dividends. Why is this hypothesis test right-tailed? I don't know. Because remember, for right-tailed, a right-tailed test would have an alternative hypothesis that looks like this. The parameter is greater than some value. So in order to perform a right-tailed test, the claim would have to be that the proportion is greater than some value. Right? They'd have to make a claim that the proportion is, greater than 14% in order for me to perform a right-tailed test. Well, they don't say anything like that up here. I need more information. More information is needed. Right? They didn't say anything about the parameter being greater than a specified value. He just said he wanted to carry out another hypothesis test about stocks that offer dividends. More information is needed to make it a right-tailed test. Again, we need to know how the population parameter and specified value are being compared. Is it greater? Is it less? Is it not equal? Right? I need to know what that alternative hypothesis looks like. And if they're just saying we're doing a test, you don't know, without being offered more specifics, what the alternative hypothesis looks like. Okay. And that's it for that. All right. So hopefully that video helps. That was just the first one, so I'll do another one. I'll have another one out on that objective, but hopefully it helps you when you're doing this on your own. And thank you very much for watching.